In 8.1, we talk about similarity in right triangles. And the first thing we need to start thinking about when we're talking about similarity is how to simplify radicals. In algebra, we simplified radicals. So take a second and refresh yourself, answer the two simplified radicals now. All right, hopefully you got 10 root 3 and 7 root 3 for the 2, as you found that in 300 there's a perfect square of 100, and in 147 there is a perfect square of 49. So we have those two simplified there. The geometric mean is different than the algebraic mean. The geometric mean is taking two numbers a and b and finding the means of those as if they were extremes in a proportion. The geometric mean between 12 and 3, 12 would be a, 3 would be b, and you would set up a proportion where x would be the geometric mean in the proportion as you see. X squared would then equal 36, so therefore x would equal 6. X can also equal negative 6, but in a geometric mean, usually we're talking about a shape or a side length or something, and therefore the negative piece of that sometimes doesn't apply. Take a second to find the geometric mean between 7 and 14. So hopefully you set up your proportion where 7 and 14 are the two extremes and x's are the two means, and therefore when you set it up, 7 times 14 is 98. You can break that up into 7 squared. When you take the square root, you should get 7 radical 2. Two theorems we have, or actually a theorem and a couple of corollaries. The first is the altitude is drawn to the hypotenuse of a right triangle. The two triangles formed are similar to each other and to the original triangle. As we saw in class the other day, we have the altitude drawn and it creates three triangles. It creates a small triangle here. It creates the medium triangle here. And then it already has the large triangle that you see here. And all of those are all similar to each other, so we can create proportions based on that. Using that same idea, we can now take corollary 1, which says when the altitude is drawn to the hypotenuse of a right triangle, the length of the altitude is the geometric mean between the segments of the hypotenuse. Therefore, if we know the altitude, then we can take D and A, make them our two extremes, and then set them up where they're proportional to each other, x being the geometric mean. Also, when the altitude is drawn to the hypotenuse of a right triangle, each leg of the geometric mean, each leg is the geometric mean between the hypotenuse and the segment of the hypotenuse that is adjacent to that leg. It seems very confusing, and the reason that I showed you in the beginning the small, medium, and large triangles is because each piece of the small, medium, and large triangles corresponds to another side length for another one of those three triangles that exist. So instead of trying to figure out, well, which is proportionate to which and how do I set it up and all this, C is the small leg of the small triangle, B is the small leg of the large triangle. A is the hypotenuse of the large triangle, and B is the hypotenuse of the small triangle. So it would read hypotenuse over hypotenuse, short leg over short leg. And that's how you would set your proportion up. Take a second and figure out W, X, Y, and Z based on the fact that you know the right triangle exists and also that Y is the altitude that you see. Okay, for W we have the following proportion. 18 is the hypotenuse of the large triangle, 6 is the hypotenuse of the small triangle. 6 is the short leg of the large triangle, and W is the short leg of the small triangle. Therefore, when we cross multiply, we find that W equals 2, and therefore X, which is the remaining of the segment of 18, would be 16. The solution for Y. Corollary 1 states that the geometric mean is the altitude is the geometric mean between the two segments. So 16, which is X, and 2, which is W, serve as the two extremes, and Y is the geometric mean. Therefore, Y squared equals 32, and y is 4 radical 2. And finally, z. Z uses corollary 2, using the proportionality that 18 is the hypotenuse of the large triangle and z is the hypotenuse of the medium triangle. Z is also the medium length side of the large triangle, and 16 is the medium length side, which is x, of the medium triangle. Therefore, when you cross multiply, you have z equaling 16 times 18. Before even multiplying those, you can pull out the factors of 4 as a perfect square here and 9 as a perfect square here. 4 times 3, which is the square root of 9, would be 12, and the remaining radical would just be 2, from 9 times 2 is 18. There are your 3 solutions for x, y, and z, as well as w. If you have any questions, as we said before, we're probably going to have some confusion in terms of proportions and how to set them up. And we'll talk about those tomorrow. Please try to answer the rest of the worksheet and bring any questions you have tomorrow.